Welcome to Spring LIB.
This is the answer to Chapter 11, problem number 59 from the Smith Organic Chemistry textbook. And this problem says devise a synthesis of the ketone 3-hexanone from ethyl bromide as the only organic starting material. So all the carbons in 3-hexanone have to come from ethyl bromide. And we can use any other reagents that we need. Okay, and so to start, I'm going to take an ethyl bromide. And I am going to do an elimination reaction with potassium terbutoxide. And that is going to get me to the alkene here. Okay, and so from that alkene, we can now brominate. So elemental bromine, that's going to give us the dibromide. Okay, and so now we have the dibromide. We can treat that with 2 equivalents of sodium amide. And that is going to get us to the alkyne. And now that we are to the alkyne, now we can start forming new carbon-carbon bonds. So we can deprotonate this alkyne with strong base, so sodium hydride. And that will get us this acetylide ion. And if we use the acetylide ion with ethyl bromide, since this is where all the carbons have to come from, we'll get a displacement. And so we end up with that. Okay. And so we now have a 4-carbon chain. And we can just repeat what we just did. So sodium hydride again is going to deprotonate the alkyne like this now. And so again, another equivalent of ethyl bromide is going to give us our 6-carbon chain, which is exactly what we need. So 6-carbon chain. So all of our carbons are in place. And now, since we're trying to make the 3-hexanone, and our alkyne is between carbons 3 and 4, and this molecule is symmetric, so we don't really need any further control than that. And so we can just use water, sulfuric acid, and mercury sulfate. And that is going to get us to our ketone. 1, 2, 3, 5, 6. Ketone on carbon 3. Okay, and so that's it. Yeah, and so since we were limited to starting only from ethyl bromide, we just had to get from ethyl bromide to acetylene, and then from acetylene, we could deprotonate that to make the acetylide ion, and then use that with 2 equivalents of ethyl bromide sequentially to build our 6-carbon chain, and then just install our ketone. And that's the answer to